we will have a very interesting topic in this session, that is linear programming, introduction to optimization and games. This topic will be delivered by expert Dr. Kingsley Emmanuel P. He is a senior scientist here in ICR NIAP. His subject of area is English economics. He has more than 10 years of experience in research and teaching. He has published more than 40 research papers in different journals of national and international repute. His area of expertise is market and trade. So I request Dr. Kingsley ji to please deliver the lecture on your important topic. Dr. Kingsley.
Thank you, Vikas sir. Thank you for introduction. Yeah, I'm very happy to deliver this lecture because this is one of the topic. It was there in the field more than 70 years back, yet still it is more relevant today. Just like regression, when we started doing regression analysis, we started with correlation, we started with bivariate regression. Then if you see the regression, bivariate regression, we hardly do that because that bivariate regression has been absorbed into multivariate regression and systems. So many models have come. The same way, it is just like a bivariate regression. It's like an old topic, yet more relevance. But if you read if you browse linear programming in your Google, very less paper only you will see that. Very less papers, less material only you will see that. It may raise a question that why we have to study the linear programming when very few researchers are using linear programming. But if you ask the question, maybe that is not the right question. We have to ask in such that how this linear programming, what name it is being called nowadays. Because it was once it is called linear programming, now no longer it is called as linear programming. It's like a mathematical programming, or it's like an optimization. So the language differs. So if you take any partial equilibrium models, any simulation models, mostly they depends on this kind of programming. I would say not a linear, but they may be non-linear. When we call about the programming, there are so many things comes, but everything has a starting point, like bivariate regression. Just like a bivariate regression, how it is an introduction to your regression analysis, and it is for all your higher level of any mathematical model, statistical model. The same way, it is just an introduction to many mathematical models. So it is now the recent word data development analysis. One way to say that. Like if you know a little bit advanced impact, if free impact models, these are all basically depends upon the basic language, the basic what you call a framework, the linear programming framework. They might have used non-linear programming. They might have used different way. There are so many algorithms out there. But thing is, it is a basic. Then only whatever you read, there only the same thing you will see that. Without the basic, you nowhere can read and understand those higher level things. So linear programming did not die. In fact, it modified itself and thriving well in the agricultural economics. Okay. So let me give an introduction. Linear programming is a better we will not call as a linear programming, should be called as a mathematical programming. It has its own vast, just like a sea, it has a vast area. Like you have a car, you can know car as a rider, only to ride, you know. You can ride a car as an engineer, the engineer who repairs your car. Or you can ride a car as a manufacturer or a scientist level. So different ways, different depth to learn. So mostly when we read any linear programming subject, so when you see that all mathematical or matrix language, notations, we easily disheartened. So today I want to encourage that do not get discouraged. We are not no scientists. Maybe we are scientists in our field. We are not scientists in optimization or what do you call operational technique or otherwise it is operational technique. But we need to know in such an extent, even if you enough to drive a car, the same way, if you know how to formulate a model is more than enough for us. No need to go for all matrix depth. There is no need for an economist, at least for an economist. Maybe needed for like a mathematician who works in the properties of all the matrices. He may need that, but for us it is not needed. So we need like a owner to drive a car and maintain a car and maintain how we maintain like a owner, just like we wash our car. The same way, we should know how to use our linear programming. So linear programming, if you divide into steps, we might not learn this linear programming like MSc and PhD level. When we read what we have been taught in our classes, mostly, I would say, it's mostly, not necessarily always, mostly, people teach that syntax, what you call the algorithm only they used to teach. Simplex model, we call simplex, big M method. These are all algorithm. There is no need for us. If you, unless until you want to read, like in depth, you want to understand, then only it is needed. As an economist, I don't need that much. I need only to formulate a model. Just like, suppose, in your land, how much, 1 hectare of land, how much seed is needed to cultivate a crop. If you have 10 acre of land or 10 hectare of land, so you just multiply it. So you just formulate it. How you just multiplication and formulation are different things. Just like in linear programming, what we call formulating a model and execution of the model. Formulation is our task, just like whether to multiply, whether to add, whether to delete, whether to subtract. These are all formulation. I want to maximize, I want to minimize the cost, maximize the return. These are all formulation things. That's what I'm interested. I'm not interested how to put form a matrix format and how to manipulate those matrices. It is not my interest. That is computer interest or computer scientist interest. So you just leave all the things what you have studied so far and focus on the simple concept I teach. I'm going to tell you. You might have studied. I think just I want to remind you. If you just happen that, I think probably you will be a better exercise, better, you have spent your time wisely today. So let us forget what you have studied as a linear programming and mathematical programming. As simple as what you have learned, all what you call primal and dual and basic and non-basic, just throw it away, all the things. These are all not needed now. We just remember only focus on formulation part. That is what we are interested as an economist. So I am social scientist. I'm talking about, I think probably maybe social scientist might be there here. So let me talk about optimization. Just let me give an introduction. This programming is mainly used for optimization only. So we use optimization in many ways, but let us talk what it does optimization. Example, if you take, you have a water, irrigation water, you need to irrigate the crop. How to irrigate the crop? Or it's like a summer time. You want to irrigate in such a way that evaporation should not be there. All the water should go into the field, means the root zone of a crop. So you are optimizing through drip irrigation. The same way we are optimizing, just like when you have limited amount of money, our money is always limited. We have to spend in such a way that our strategic interest, our long run interest should not be compromised. Only the unnecessary thing can be compromised. So you make a priority, you prioritize the things, the goals. The same way here, what you are doing, you are distributing your scarce resources. You are resourcing in such a way that you get maximum benefit. One way to say. Otherwise, you get less pain with the less pain or less cost. That's all. These are two things we often do. Like we have money, we want to enjoy it, so we know what to purchase. So someone it may be a hotel, someone it may be a bar. So it is a kind of a maximizing your pleasure. So maximizing your utility. So another to say that you want to minimize your cost, your pain. So these are a major objective we are talking about. Maybe the later class and Dr. Premchand will talk about multiple objective when it comes. So this optimal allocation, what is this optimization means? Determining optimal allocation of your scarce resources. The word is very important. It is only about scarce resources. It doesn't talk about the plenty of resources. There it won't work. This method, it won't work when you have plenty of resources. Just like your air is free. In that case, it won't work. This methodology won't work. So you have to remember, optimization concept comes and effective when there is a scarcity. So determining optimal allocation of your scarce resources in a such a way that your profit or your utility can be maximized or your cost or pain can be minimized. So this is simplest way. You just remember, forget everything. Either in the life you want to maximize the thing or you want to minimize the thing. Minimize the pain and maximize your joy. Maximize your utility. That's what our concept is. So optimal maybe some maximization of utility or minimization of cost. Okay. So now we'll come to a little bit we introduce. This optimization we do every day. Every day, as either we know it economics or social science, we do it in our life. When you have when you are feeling thirsty, you know whether to run or whether to sit in the shade. So you know it. So our body does it. So this is that what you are doing internally is just scientists have developed in a little understanding way. So that large, big decision can be made in the basic, in the way intensely we are trying to be, we are trying to optimize the resources. How our individual person optimizes the same way, the same methodology we have extended. It has been extended. So that's what this optimization is. So mainly here we are talking about constraint optimization. When it comes to optimization, it's a constraint and unconstrained optimization. Maybe we might have studied in your farm management. That is when the resources are not limited, then you go for unconstrained limitations. That means suppose you have a water is plenty, then you apply in such that your marginal product is zero, MP, marginal productivity of your crop is zero. That's what you apply. But it is naturally happen in the world. Always our resources are constrained. So we always use constraint optimization. Okay, these are all constraint optimization, basically. But when we come to the programming part, the programming, this linear programming, it can be linear or integer or quadratic or non-linear. So there are so many types are there. These are all basically dealing with constraint optimization. That means when the resources are limited, always it's a constraint optimization. When there is a scarcity, it's always constraint optimization. There are so many methods are there. We can say it's a method, linear programming. So it depends upon the requirement, the way we formulate the problem. We need different approach or method we need it. Okay, it may be a linear or integer or quadratic or non-linear. So still many are there, but you have to remember one thing. If you can understand, if the linear programming script or the things can make some sense to you, oh, you understood a lot of things. Then integer also will be much easier. Quadratic, all for every programming. This LP is a stepping stone. Without that, we cannot cross into optimization or nor your mathematical programming. Okay, so let us talk about linear programming. So what, in the sense, I am going to talk about linear programming today. So let me stress on this. So what is linear programming? Here, when you talk about this programming approach, there are two things are remaining here. One is your objective. Another thing is that your constraint. The same way in your life also. So you know where is you need to go. Suppose you are going to your hometown. You know what is your where is your hometown is there. Then what are the means are there? These are all your constraints. How much your money is there, how much time is there, how much pain you can bear with that. So all the limitation, constraints. So there are two things you need to remember. One is objective function, another is the constraint. So that's what you talk about. So the constraint, like studies in the linear programming studies a case in which objective function is linear. So that sense that our objective function, our goal is a linear. I can say sometimes our goals are linear, sometimes our goals are non-linear. Example, if you take if you read, if you take our own example, just like when you are feeling thirsty, the way you drink a water, or the desire to drink a water may be much higher when you feel there is no water. Then the desire to consume water is very less when you have plenty of water. Though the same water is, but the response, if you see that when there's a danger is there, your pressure is so high. When you see that everything is there, your pressure is very less. So it is a non-response. It's just like a non-linear response. Our system is so non-linear. But this is it's a linear thing. Linear in the sense that it either scarcity or it is a danger or not danger. It always behaves in a straight line. That's what we call it. It's a linear goal, linear objective function. It's a limited version of a non-linear objective function. So linear things is a short run is good, but in the long run it may not be that good. Okay, it is better to have a non-linear. The life is all about non-linear. If you read anything, it is always non-linear. The response is non-linear. So we just assume that it's an objective function. The way the system behaves is like linear. So objective function is here linear. F. Objective function F is linear, and the set A is specified using only linear equalities and inequalities. So I told you that one is objective function. The second thing I told you there, that is a constraint. The constraint is we call it as a equal. Example is called equal. Equal symbol we always call it equal. So the one example I would tell you that. Suppose I want to maximize the net revenue. So I want to maximize the net revenue from rice or other crops, subject to my concern is what? Irrigation availability, irrigation need and irrigation availability, fertilizer need of the crop and fertilizer availability, budget expenditure, what your money need to produce the crop and what is available. So maybe sometime you may be over surplus resource. Sometimes you have a constrained scarce resource, limited resource. So depends upon that we maybe call less than equal to or greater than equal. That's the simple thing. You just remember only the two things: objective function and the resource constraint. Always the resource constraint, it never be always equal. It always not equal. That means it may be greater than equal.
Actually, sir.
Yes, sir.
Sir, actually your slide are not moving, sir.
Yeah, I'm sure I understand that.
Okay.
So this is what I'm saying, that this the set of A is specified using only linear equalities and inequalities. So inequalities. Okay. So either equal or not equal. Not equal maybe less than equal to or greater than equal. That you need to remember. Okay. So this is what the linear program is. You all you forget. Whatever you forget, remember only two things. One is objective function, another is constraint. If you remember these two things, just like in your life, you know what is where is your goal, what is the available means, are your constraints. So you just remember these two things, you understood 50% of linear programming. Okay. Now we come to integer programming, but many times our integer programming is a bit different, a little bit different from linear programming. It says that studies linear programs in which some or all the variables are constrained to take integer values. Example, I will tell you, water, you can divide the water equally, like a land also you can divide. But sometimes livestock is that you cannot divide. Livestock always 1, 2, 3, 4, 5, 6. It's not an integer. It cannot ever be 1.5, 1.2, 1.3. So in that case, when there comes 1, either should be in integer form, either 1, 2, 3, 4, 5, like that whole figure. Then you need to use integer programming, not the so integer That will be helpful. So these are all little bit modification. There are so many versions of that. I don't want to put you more burden on it. Just I want to give a little flavor and to give you interest on linear programming. That's why my objective today is. Okay. Next is quadratic programming. Here I told you that our objective function in real world is a non-linear. So it is quadratic programming is a kind of a non-linear, but depends. Non-linear when you talk about but mathematically it may be a quadratic, it may be a cubic form, it may be a power form. There are so many forms are there. So this is quadratic version is just like a x and x square. In that case, it is we use our objective function is non-linear to some extent. So our while our a, that means our input constraints are equalities. They are all just like a linear only. Maybe you will understand what when I speak a little later. So in that case, we use quadratic programming. Similarly, non-linear programming is other, so it can take many things. So either both objective and constraint. So like that, stochastic programming is there. Here, when you talk about the linear programming, we always assume either it is our objective function. Example, our objective function is we want to maximize our net revenue. Net revenue from the agricultural production. Maybe you are cultivating crop like rice, corn, cotton. There are some crops you are cultivating. Okay, so we are just assuming that the market price going to prevail during your harvesting, selling of your crop produce. Already it is known. That's what we are assuming the.
That slides are not moving.
Yes, it will move. I have not yet moved it. Just I'm explaining it. Okay. So the constraints are also limited, like water requirement and water availability is limited. So water availability, suppose you want to give a range of value. In that case, it's a random, it's a range of value. Then in that case, we use stochastic programming. Okay. Then we go for dynamic programming. So in that case, dynamic programming is like it is also one way. I think it is recently it is being largely used. So every problem is it's a linear programming. It's a different time version. Like your production. Suppose you are assuming that your form of production response depends upon it's not only depends upon the last year. It may be over the period what he accumulated the knowledge. The price knowledge, how the market will behave. So in that case, if you want to accommodate, then we have to use dynamic programming. So like that, there are so many versions are there. I'm just giving you this as a limited important one. Okay. So these are all the whole tree. Still, there are so many versions are there. I'm not going to touch that. Okay. Now we'll come to specifically linear programming. Okay. What we do with this linear program? What we can do? Okay. So usually agriculture is what we bother. We bother about regional crop planning, the sense that suppose you have a crop, what crop you should cultivate. That will maximize your revenue with the resource constraint. Suppose you have a resources like a labor, land, irrigation is that is your resources. You know what are the crop requirement and what is the available with you. These are constraints. Then you know your objective is maximizing your total revenue or net revenue. So you are here. What is your main objective is allocating area under different crops. You want to allocate more area under the cotton. You want to allocate more area under the rice, or you want to allocate more area under the corn. So you are allocating some land. So basically that is dealing about allocation problems. Okay. Another is diet problem. It is like mainly deal with diet. Nutritionists are like animal husbandry people. They usually deal with that. Like what is your animal feed requirement. You know what are the way that a nutrient can be obtained. Then you are trying to minimize the cost of producing that feed. So you are trying to minimize the cost. In the first one, you are trying to maximize your net revenue. Here you want to minimize the cost such that your nutritional requirement is met. So that is a diet problem. So again, blending problem, it is something related to diet only. So these are all. Then important thing I will talk about as agriculture economist, data environment analysis. This is also one way of the application of linear programming. Inventory planning, transportation problem, assignment problem. So there are so many out there. These are all we might have studied, but just I am giving you what is related to our field. Now I am coming to the exercise. Okay, we are going to do exercise. I hope you have a laptop. If you have a laptop with you, just keep open it. Excel sheet is very important. So one question we'll start with one question. It's a hypothetical example. Farmer A has 100 hectare of land. Okay, he has a land. He has a labor, that is 500 days of family labor. He can produce only 3 crops. Kharif crops, let us assume that one of the Kharif crops: corn, rice, and cotton. Okay, so all the data are there. Do not relate this net revenue with your actual figure. So these are all just for your example. Okay, these are hypothetical. And similarly, labor recommend also. Just an example. Okay, so we have a. Just I want to ask you. Just you think about yourself. What are the resources are given here? What are the resources? What is our objective? We just think about. I'm just asking the question. From reading this question, what do you understand? We need to, I told you, linear programming itself depends upon 2 things. One is objective, another is constraint. Here we have to understand what is our objective and what is our constraint. Okay, just I'm telling now the answer is our objective is maximizing net revenue. That's what I'm interested. Farmer has 100 hectare of land and 500 days of family. He can produce 3 Kharif crops. So what is interested? A farmer interest is maximizing his revenue. That is what? How he can maximize? So a lot area under the profitable crop in such that his profit his total revenue is maximum. So where the profit is more, you need to allocate more area. He basically to say that where the profit is more and less resource requirement, he allocated more. Where there is a less profit and more resource requirement, allocate less. So this is the simplest way to say that. So our objective is maximizing net revenue. Our constraint is what? Labor resources and land resources. Labor availability what? Labor availability is 500 days. Land availability is 100 hectares. No matter how he produces it, he cannot increase those resources. They are all now limited. That's what we just assumed that. Suppose you just he has a plenty of resources available, then in that case it won't work. Okay, only you have to remember this optimization techniques will work when there is a scarcity. The resources are limited. So you no need to mention when you are formulating a model, no need to put all the resources. Only you need to formulate the resources which are limited. If your resources are plenty, you don't need to mention it in that equation. There is no need. They are not going to bound your model. They are not going to constrain your model. So only you focus on those variables which are limited. Okay. So I told you that the 2 things I remember. One is your objective function. That is our maximizing net revenue. Another thing is our resource constraint. One is labor resource requirement. Another is land resource requirement. These are the 2 things. Okay. So the question you have read. Now, what is availability? The resource constraint, there are 2 things. One is resource need should be less than that of resource availability. That is the idea always. When you spend, you will not spend on your whatever the money is available. That is your maximum limit. You will spend within that range only. So that is the idea. Suppose in the case of blending, you know, just I don't want to confuse that. Let us take only focus on this. Okay. Now let us how we can formulate this. This is the this slide. Hypothetical example. It's a slide. It's just like a small question. Now how we can formulate the model. So I am telling again, linear programming. The most important thing is formulation, not the execution. Formulation is the most important thing. Execution, computer will take care. You don't bother about that. First, if you know how to formulate it, remaining thing computer will take care. No need to worry about that. Okay, now we are just trying to formulate this model. Okay. So now our case, I told you what is our revenue. We are trying to, you see that there are how many equations are there? Objective function, resource equation, non-negativity equation. You even forget the non-negative equation. You just forget it. Only you remember objective function and resource equation. How we can write this objective function? So what is we are interested actually? We are interested in maximizing the net revenue. Net revenue, how it comes is nothing but some product of your net revenue or net revenue times area under the crop. That is nothing but, suppose let us assume that each crop you allocate a per hectare of land. How much you how you write the equation? It's like a sum. Yes.
Now, slides are moving or not?
Slide is moving. What's the problem? It's I mean objective function, resource equation, non-negative equation. Is it
No,
opening?
sir, it is not. It's not coming, sir.
Oh, yeah. I'm sorry.
We are supposing that. Yeah, now it's moving.
It's moving.
Yes, sir. Now it's moving. Because we were supposing you were.
Okay. I'm sorry. So this is a hypothetical example. Is it visible now?
Sir, it's not in a slideshow mode actually.
Slideshow mode.
Yes, sir.
F5. F5.
What about now?
Now it's still not.
Not moving. I don't know. Somebody has to help me now.
If you put
Help me.
F5.
Okay, at least is it moving? At least you are able to see the slide, whether it is in slideshow mode or not, whether it is moving or not. Are you able to see the text or not?
It is a hypothetical.
It is visible, but it's not in a slideshow mode. It is visible.
Are you able to read it now? Maybe
Yes.
I have put it in slideshow mode only, but I don't know. Maybe when Philip comes,
It's not in slideshow mode.
Yeah, I have put it in slideshow mode only, but I don't know what to do beyond this. Okay. So this is a question I have given you. Okay, hypothetical example. A farmer A has 100 hectares of land and 500 days of family labor. He can produce 3 kharif crops, namely corn, rice, cotton in his field. Okay, this is a question. And we have given that what is the labor requirement and what is the net revenue from each crop that we have given the data. So with that, we need to formulate a model. That's all. If you know formulation part, you are more than enough to run a linear programming. So you need to understand. So that's what I'm talking about. Formulation part. Formulation, you need to remember 2 things. One is objective function, another is resource constraint equation. Okay, I'm going to the next slide. You see that whether it is visible or not. Formulation, is it visible, sir? Because sir.
Yeah, it is still a hypothetical example coming.
Oh, I don't know.
Next slide is not coming.
Let me try. Let me close it again. Open it. Huh? Now you see that.
It's the first slide.
Okay. Second slide. What is optimization? Is it visible?
Not visible, sir. So it's still first slide is coming.
I
No,
know
sir.
what to do.
It's not moving.
Oh,
And now it's moving.
moving. Yeah.
Yes, sir. Optimization tree.
Okay. What about linear programming application? Is it visible?
No, sir. It is in.
Okay,
yes,
maybe I'll do one thing.
Yes, sir. Now it's coming. Coming.
First you answer, then after share, sir. That will be visual.
Yeah, I have done thrice now. Maybe I'll do it once again. Yeah, coming to formulation part.
Yes, now it's coming.
Formulation is what you are able to see formulation.
Able to see.
Yeah. See, I'm talking about how we can formulate a little problem. That's what I'm interested. If you can understand that, it is all over. My objective is today is accomplished. So main objective is, our objective is maximizing total revenue. Second objective is a resource equation. These are the two things. If you got through your linear programming, all modeling is over. So we are talking about what? Maximizing the total revenue. How will you maximize your total revenue? Total revenue, what? It is nothing but net revenue times area under the curve. So we have taken, we have a 3 crops. So profit and area under the crop. Suppose a corn is a area under the crop, rice is a area under the rice, cotton is a area under the cotton crop. That's the meaning. So you have to remember that. So this is what then our total revenue. That's what I have written the equation. Now you don't bother about how much the area, value of corn, value of rice, value area of cotton. You don't bother about it. Only you remember net revenue, total revenue from the farm is equal to sum of product of price or net revenue times area under the curve. That's the smallest formula that we know it from the beginning. Okay, so that's what I have written it here. So only I have not specified area under the each crops. Either area under the crop, I don't know. Area under the rice, I don't know. Area under the cotton, I don't know. Just only I have written the only general equation, that is 109 is the area under the net revenue of corn times area under the corn, plus 90 is nothing but net revenue of rice times area under the rice, plus 115 is nothing but net revenue of cotton times area under the cotton. So I have not put area under the cotton, I have not specifically value, I have not put it because that value is generated by the model. Okay, only I have to put what are the, just put it or 1 the same thing. Next, subject 2. So objective function is over. Objective function nothing but sum of product of, nothing but some product of net revenue times area under the crops. That's the simplest way to express. Next, this is our objective function. What is our resource equation? The resource equation could be 2 because our resources are limited, resources are land as well as labor. Okay, you have to remember, let us first solve about labor, because in our case we are only talking about area allocation. Majorly we are allocating about the area. Okay, so our model has to return the result, that is area under the each crop. Okay, so only one labor, only one resource, that is labor is remaining, that is 6 is nothing but labor requirement to produce a hectare of corn. Okay, I don't know, I have not specified either. Yeah, it's a farmer 100 hectare of, it's a hectare. Okay, so 6, you read as a resource equation. In the second equation, labor equation, you read it 6 times corn, nothing but 6 is a labor requirement of corn times area under the corn, plus 4, nothing but labor requirement to produce a hectare of rice times area under the rice, plus 8, nothing but labor requirement to produce a hectare of cotton. So this whole equation, if you see that left hand side before to less than equal to, you see that these are all talking about labor requirement equation. These are all resource requirement. The right hand side talking about what is a resource availability. You have to remember that 100 and 500 it is talking about resource availability. Left hand side only talking about resource requirement. Okay, so we are writing what is a resource requirement. Then we come about our area equation or land equation. So because all the resources were specified per hectare, so it should be put all the land is 1 into corn, because so 1 hectare of area under the corn, 1 hectare of rice, 1 hectare of cotton should be less than equal to 100. That means land requirement should be less than equal to land availability. Labor requirement should be less than equal to labor availability. So only these two sets of equation if you have got it, your problem is solved. Only I'm reiterating again. Objective function, another is resource equation. Objective function, you are trying to maximize the total revenue. What is the formula for total revenue? It is nothing but sum of product of net revenue times year under the crop. The same way, what is a resource requirement? What is the formula for resource requirement? That means resource per hectare is needed and year under the crop should be less than equal to resource availability. That is the simplest way. It is a simplest expression. That's all. It is no complicated things are there. Objective function and the resource equation. Then comes the non-negative equation. Is objective is that what we cannot allocate area in minus. That means our area allocation either should be 0 or in positive. It can never be negative. So in that case, we are applying.
We are having only formulation slide.
Yeah, that's what I formulation slide. I'm in formulation slide only. Okay.
Yes. Okay. Sir.
Okay. So the same equation, if you can able to write it in your pen and paper. So remaining thing you can translate them into an Excel sheet. That's all. This is the first the formulation part only little bit. It doesn't come with a single day. You need to practice it, keep practicing. Then only it will come. But it's an idea is simple. But maybe for the beginner, it may be a little difficult writing so many things. So you need to keep practicing. Okay. So this equation, if it is being translated into Excel, then your problem is solved. Okay. So you just see that these are all Excel sheet, how I have done it. If you read it in a little bit linear programming notation, they call it C matrix, B matrix, A matrix. Just I want to tell you, nothing but these are all what you can write it down. The objective function or your net revenue comes now, what are the value? Either it's a maximization of net revenue or minimization of cost. Cost incurred or net revenue you realized. These are all C function, we call it. Whatever comes in your objective function, that we call it as a C matrix. Then whatever the resource availability, the matrix indicate the resource availability, 100 and 500. That is nothing but B matrix. Then resource requirement matrix. You see that 111 600. I think probably maybe let me. I don't know whether it is visible or not. Land 111 648. This round it indicates A matrix. Nothing but technical coefficient or resource requirement. These are basically talking about resource requirement. Okay. Another thing it is talking about objective value. See, these are all objective value is one you will get once you realize it. Once you run the model, you get. So what is the total revenue? That is your objective value. Here 9,950. That is objective value. So it is nothing but sum of, or we can say that total sum of product of net revenue times year under the crops. So otherwise in an Excel language, it's a sum product of net revenue and year under the crops. So 9,950 is objective value. So it is, we call it objective value. Okay. Then you see that another nearby less than equal to sign 100 and 500. Maybe there are two sides are there. Left hand side I'm talking about 100 and 500. So before less than equal to, that is resource used. Basically, linear programming solver, the Excel solver demand only two things: objective value and the resource used and the resource availability. Remaining thing it doesn't bother. These are all for your own understanding. Okay. These things, resource used and resource availability. So just I want to reiterate once again, our objective function subject to resource used should be less than equal to resource availability. That's the simplest thing. I want to maximize my pleasure such that resource usage should never exceed resource availability. It's a basic understanding. Your resource usage never can exceed your resource availability. Then you cannot solve your problem. So always resource usage should be within the limit of resource availability. That's what I have expressed in mathematical language. That's all. So if you can do that, it's all over. Okay. So then we are going to solve it. So we are going to enter into Excel. Okay. The one problem with the Excel in this remote learning, I cannot show you all the windows. I can show you the Excel sheet, but not all the windows. Okay. So what we will do, we will just take a snapshot of these figures. Then I will enter the data. So I'm just unsharing this PPT. Okay. Now we'll go into Excel. Yeah. I'm sharing one sheet. Sharing, resume share. Oh, not resume share. New
Coming,
sheet.
sir.
Just hold on. Share screen. Microsoft Excel. Windows share. So you see that one Excel sheet is there or not?
Yes, sir.
Okay.
That is good.
See, let me write the graph also so that we will not can get confused. So what is our first graph? That is corn, rice, and cotton. Okay. I'm typing corn, rice. Okay, these are all our okay. So are you able to read the title?
Yes, sir. We are able to read.
Okay. So this is how we have formulated. So you have to remember our this 100 and 500. It talks about resource availability. We have to compute resource usage in the Excel sheet, and you have to compute what could be the objective value. Okay. Now let us add one more row that is called decision variable. Okay. Let us call. I'm introducing one more row. D variable. Decision variable. I hope in this all the figures you don't have any doubt. I just assume it. Okay. I'm going to next line, decision variable. What is the decision variable? Decision variable is the solver in Excel. It give me how much area should be allotted, or what is the decision variable, what is the magnitude of decision variable is going to show after solving it. Okay. So let us we'll use it. We have not introduced any formula right now. Let us first what we do, put 1 hectare under corn, 1 hectare under rice, 1 hectare under cotton. Why I have written? I want to tell the model. Just I need to write the formula. Okay. So suppose let us allocate it 1 hectare under each crop. So what could be our objective value? What could be the resource usages in terms of land as well as land? That we will just calculate it. That will be useful. Okay. What we can do? I think you see that whether my formulas are appearing to you or not. Okay. So what I need to find out objective value, that is my net revenue, total net revenue. So how I should compute? Maybe let me write decision variable, or in that case, area under the crop, area under area crop area. Let us write crop area. For your understanding, I have written crop area. Okay. Just we have put 1 hectare under each crop. Okay. So now I want to calculate what could be my objective value. That means your total net revenue, and what could be my resource usage. That's how I have to calculate it. Okay. So how should I calculate? Anybody can tell if you are happy to do that. Otherwise, I'll do that. Okay, I'll do it. So what I need to do? Area under the crop multiply by net revenue. Right. Maybe I'll just write it here. Okay. Okay, just adjective value done. I will write it our net revenue. Just I will write net revenue. Our objective is maximizing net revenue. So 109 is nothing but net revenue from corn, rice 90 rupees per hectare, cotton 115 per hectare. Okay, these are all, there is no doubt in it. So now I am going to write a formula for it. Okay, so what is the formula of total net revenue from farm? That means area under the corn 1 hectare times 109 rupees plus 1 hectare in rice times, that is not area under the rice times net revenue from rice plus area under cotton, that is 1 hectare times net revenue from cotton. So if you sum up 314 rupees, just right now we make a small dummy calculation so that we enter the formula. Okay, so our formula is finding the objective function, that is not total net revenue and resource usage. So what is the formula? Is nothing but sum of product of area under the crop and net revenue. So that's what I have done. If you, I think probably if you are able to see my formula, you can see it. So, okay. Now we have to find out land. How will find out the land usage? We know it. What is the crop area? We know it. What is the land usage? So what could be 1 into, that means crop area times crop area needed plus crop area and rice times land needed plus crop area under cotton times area needed in cotton. Okay, so 3 hectare. So if you allocate 3 area across each crop 1 hectare, so actually we will be using 3 hectare of land. Similarly, labor, same formula, area under the crop times labor use plus area under the rice times labor use under rice plus area under cotton times labor used under cotton cultivation. So total 18 days of labor use. So this is the formula. Just I have not done any big calculation. This is a small calculation. Okay. So we can use simply this, that, and there is no issue. What actually we do that, just I am putting this figure outside. So save the time, we just fix it. That's why it's just like a simple trick. That is, we are not doing anything. What I would do it, instead of writing like this 1 by 1, because suppose you have a big program, big problem, then writing line by line, it will be a very difficult task. So what we will do, we'll just write some product of area under crop area, comma, and net revenue. So same value does come. So what I need to do, just I need to fix it. Fix the area under the crop. Okay. I fixed it, I drag it. So the value will not going to change. Only a small trick. I have not changed the formula. Anything. Just the same formula. Just using small trick, I reduce my wastage of time. That's how I have done. So this is over. Then this is your part is over. Now the part of computer. Okay. How will do that? But I'm now a little bit problem because when I open the solver, that may not be visible to you because let me try. Otherwise, you just open the solver, you can see, you can solve simultaneously what we have done in the Excel sheet. Okay, so that you can relate. When I open my solver, that window may not open to you. So there's a problem. So I need to go to solver now. It may not be visible to you. For that, I can do nothing. Okay, what I need to do?
Sir, it is visible.
Is it visible? Oh,
yeah.
I am very much happy. Thank you. So you see that what is the solver window? What are the variables are available? One is set objective. The next row, it is talking about what, whether you are maximizing, are you minimizing, or something like you are equating value of. Then another tag, what do you call a space is coming by changing variable cell. Then it comes, what are the constraints? Then comes what the solver you are using, whether you are using simplex LP, whether you are using GRG nonlinear, whether you are using evolutionary. These are all not needed. Only you need to worry about simplex LP. Okay, this is a solver. We have studied in our MSc all simplex LP only. That is how to solve it. But actually, what we have done is a formulation. Formulation, what you need more, not the simplex. That computer will take care. Okay. So now, what is our objective? We have to show our objective value, where our objective value is nice. Set objective. That means, where is our objective value? What is our objective value? Our objective value is total net revenue from the firm. That is nothing but 314. The cell of 314 is our total objective, our total revenue, nothing but our objective cell. So I am just indicating my objective cell. Okay. So I'm just putting my cursor on 340. Done. So we'll go to next one. What is our goal? What is our objective? Whether it is maximization, whether it's a minimization, or just equate. Our objective is maximization. We want to maximize the net revenue with a given resource constraint. So we click or you put your cursor on the max. Okay. Then we are going to third row, that is changing variable cell. What is our changing variable cell? What you ask? Changing variables, you see that our decision variable is the changing variable cell. If you put different values in the place of 1 we have kept in the decision variable, you put different value, your objective value will change. So you can, there is no need to solver. If there is a small calculation, you can do it and allocate randomly some figure on decision variable, the value will come. But it is a systemic way that if you show it, it will take care of all things. So what we'll do that, we will indicate the 3 cells, 111 from B6 to D6. So that is my changing variable cell, nothing but my decision variable. Okay. In linear programming language, it is a decision variable. Excel solver language, it is called variable cell. Okay. Now we have to introduce constraints. Okay. How we can introduce a constraint? What do you need to do? Just add land. Okay. So if you see that when you put add, you'll get a 3, just wait, I'll come. So 3 cells will be there. One is cell reference, another is equality and inequalities, that means less than equal to or greater than equal to, another is constraint. Okay. So what we have to show first, my labor constraint, I need to mention it. So I'm putting my cursor on 3. What is my inequality? Less than equal to, already it is there. So I just less than equal to only I'm adding it. What is my constraint? Just show 100 land constraint. So once that 3 cells are filled, you go to OK or add. Let us go to add because we need to add another constraint. Okay. Next, labor. I'm cell reference, I'm giving 18 cell, the cell value of 18 less than equal to constraint. I'm indicating the cell where 500 located. So this is my constraints. Only 1 objective function, 2 resource constraint. Okay. Now we are ready to run the model. Simplest LB already I mentioned. You remember that make unconstrained variable is non-negative. Okay. Let us run it. So it gives me OK. What it says, this is my decision cell. Let me put it in red color or yellow color. And put red color. I hope it may be a little visible to you. According to that, this model, it says If you allocate area under corn and rice, your net revenue will increase. That's what the model says. Suppose this is the best way. Suppose you want to change the model. Like you want some area under the cotton because maybe you think that maybe in your own personal requirement or your contract, something you want to add something, then what we should do? We need to extend the model. But now I want, before going there, I want to confirm from your side, you got something out of this or not? Because until you understand this, what you have understood, what I told you, and if I go there without understanding, then it will be another headache to you. So any doubt you have, let us go to the next one. If you can raise your hand, let me see how many of you are listening now. Let me see the chart. Okay, I'm seeing only that time is ending 3:40. Excel sheet is not clear. Okay. Okay. So if you have any doubt, you can ask. Otherwise, I'll go to the next example, or I'll stop here. 3:40. So what shall I do, sir?
Sir, expert is waiting for the next lecture.
Okay. So I am closing here. Okay. I don't want to trouble you. Okay. Thank you, sir. So
I request the participant, if you have any query regarding this, please ask our sir if any query is there regarding this topic, important topic. Sir has explained very nicely with a very clear example in Excel. There is no issue coming. Thanks, sir, from the side of participants, organizers. I am thanking you for a nice presentation on a very important topic, sir. Thank you, sir.
Thank you, sir. Thank you.
Hi, Dr. Kinsley.
Yes, sir.
How are you?
Oh, my friend, how are you? Oh, I miss you now. So you call me evening.
Yeah.
Okay, thank you. Bye.
Thank you, sir.
Can you give your number?
Yeah, you take it because number. I will call you. Okay, 901 3848
Wait. 90
1
1
38
38
48
48
736.
736. Okay. Thank you, dear.
Okay, thank you. Thank you. Nice to see you. Bye.
Thank you, sir. Thank you.
Okay.
Now,
I can close it.
yes, sir. Yes, sir. Now we will have another topic here, the multiple objective optimization for sustainable agriculture. This will be taken up by Dr. Premchand. He is a senior scientist in ICR NIAP. He has more than 15 years of experience in different areas, and he has worked in different institutes. More than 7 years he has worked in Atari Jabalpur. He has served in Amity, Rajasthan also. His area of expertise is monitoring and evaluation, ICT in agriculture, agriculture sustainability. He has published more than 50 research papers in different journals of repute. He has received the Young Agriculture Economist Award from NAS and a member in different agriculture research societies. So I request Dr. Premchand sir.
Come. Yes, welcome.
Please deliver the lecture on a very important topic, multiple objective optimization. Please, sir.
Thank you, Dr. Saab. Thank you very much. Am I audible?
Yes, it's audible.
Yeah, then let me share my slides. Are these visible?
Yes, it's visible.
Full screen?
It's not full screen.
Yes, sir.
Okay.
Yes, now.
Thank you, Dr. Saab. Good
Thank you,
afternoon. I hope that in the previous lecture, some concept you can understand. about the optimization, particularly the linear optimization, linear programming. I will move but bit forward from this LP. I will be explaining about multi-objective optimization, because in real life our objectives are multiple. No, we want to maximize return, at the same time we want to minimize our water, we want to minimize our gaseous emission, we want to maximize our production of, in fact, cereals, pulses, oil seeds. So actually we have a number of goals. So single goal cannot solve this problem. So I will be dealing with multi-objective optimization, particularly goal programming, how to solve a goal programming problem. But before that, let me ask few things. Hope you all are using this one, laptop or desktop. Say yes or no.
Yes, sir. Desktop.
Desktop. No, only one participant said yes. What about others? Are you having laptop or desktop, or you are attending with mobile phone?
Sir, I am from mobile phone and at the same time I'm using my desktop.
Then it's okay. Desktop, it's okay. Laptop, it's okay. Mobile phone, from mobile phone, I think it will be a bit difficult. Let me check who was now. Bit difficult to understand. Because you will be practicing simultaneously, and if yes, if you have laptop and desktop, kindly let me know whether you have solver add-ins installed in your PC or not. Please, yes or no.
Yes, sir.
Only one. Others,
Laptop, sir.
do you have solver add-ins installed in your PC or Excel?
No, sir.
No, you then do it.
Okay,
Steps
sir.
are very simple.
Yes, just
Very simple. Steps are very simple. So do it. Those who have laptop and desktop, kindly install Excel solver add-ins in your Excel. Steps are here. Add-ins you can do, no? Add-ins are very simple to install. Please install. It will take not more than 3 minutes or 4 minutes. Let me demonstrate it, how to install add-ins. No? Shall I do it or you will do it?
we are doing just.
I'm
wait,
not
sir.
getting response. No, please respond me. No, actually, it will be
Sir, doing, sir. Just wait, sir.
okay. Do it.
Yes, sir. We got it, sir.
Got it? No, it won't take much time. If you have any problem, kindly, I don't want to switch screen. Otherwise, it will take time. So, yeah, I have mentioned here the steps. If you face any problem, kindly let me know. Once done, kindly say yes. You write in chat box, yes.
Done, sir. Done.
Done. Okay, good, good. Good. Yeah, very good. Done. Good. Good. So shall I move forward or should wait?
We can proceed, sir.
Okay. Thank you, Doctor. So,
Yes, sir.
shall I
I have done.
repeat? Pardon?
Sir.
Shall I repeat some concepts, or shall I straightway go to the exercise?
We can have some basic concepts.
Some basic concept.
Yes.
So, as name suggests, multiple or multi-objective optimization problems deal with the objective more than two or more than two. Then we call it multi-objective, and it is different from LP in terms of expression. Otherwise, it's a kind of extension of LP, not different. No. We solve it in a different through different method. And here what we do is finding a rigid solution or a single solution. What we do is we try to get the best possible satisfactory solution that depends on our desire, what we want. So what we do is we convert our objective functions into goals and then solve it as a LP problem. So it is an extension of LP problem. So what I will do is first we'll formulate a LP problem and then we'll transform it into a goal programming problem so that you get better idea. So, but before that, let me recap some concept about this goal programming or multi-objective programming. First is decision variable. As name suggests, decision means decision variables means a variable or a factor on which we have control, or a manager have control. As a farmer, we have control on type of crop to be grown, area to be allocated under different crops, number of livestock to be reared, type of livestock to be reared, whether to go for rain-fed or irrigated, whether to use basmati rice or a plain rice or a non-basmati rice. So these we can decide, but we don't have control over water availability. So these are not controllable. So decision variables are the variables on which we have control. So we can do only with decision variables. Constraint will be constraint. Then comes the criteria. Criteria means the measuring rods against which our solution is called as good or bad. Like cost, whether we want to minimize it, profit, whether we want to maximize it, time, whether we are going to take 2 crops or 3 crops. No, we adjust our cropping in such a way that we can take 3 crops. So we are adjusting the time. Our criteria is time. Then externalities. Our criteria is generating minimum quantity of residues. So these are the criteria against which the solution is called as good or bad. And then objective. Objective, it's a function that we want to achieve. To want to achieve means either maximization of return or minimize return, maybe maximization of welfare, or minimization of cost, or minimization of externalities. And then comes the aspirational levels. When we attach some numerical value to these objective function or objective function, we call it as aspiration. Suppose if I say I want to maximize net return, and if I say that I want to achieve my net return rupees 1 lakh, so it's my aspiration level. I want to achieve it I want to bring it to 1 lakh rupees. No, it's my aspiration level. Or I want to reduce my water level to a certain level. These are the aspiration level. And what is this goal? This expression expression or these aspirations and objective functions together are called as goal. Yeah, let me give some example. I say maximization of net return equals to 3x1 and 3x2. What is decision variable here? X1 is decision variable. X2 is decision variable. So we can change this. No? This is objective function we want to maximize. But when we say we attach a value 1 lakh rupees to it is aspiration level. We want to target to, we have targeted to achieve or to bring it to 1 lakh rupees. So if I express 7x1 plus 7x2 means equal to more than equal to 1 lakh rupees, it becomes the goal. But how to solve this? How to solve this? Because computer doesn't understand any inequalities. So we have to express it in the form of equations. And this expressing it in the form of equations is called as formulation of problem. Then comes the deviations, goal deviations. If we underachieve, we are deviating. If we overachieve, we are deviating. If we are overachieving, we call it positive deviation. And you know, if a goal function to be converted into an equation, we have to subtract the overachievement from the left hand side so that our equation is balanced. So what I'm doing here, my target is, suppose my target is 1 lakh rupees. 1 lakh rupees. I have achieved 1 lakh rupees, 1.1 lakh rupees. So 1.1 lakh, 1,000 rupees, or sorry, 10,000 rupees. I have to subtract from my left hand side so that the equation is, this expression is equated. The equation is formed. Similarly, negative deviation. If we are underachieved, we are not able to achieve the targeted, the amount targeted, the difference is underachievement. So what we have to do is to equate the expression, we have to add this negative deviation to left hand side. Then only our equation will be balanced, no? Then if I don't want to either negative or neither negative or nor positive, or I want both, I'm not sure whether I can accept both. I can accept both. I can accept less also. I can accept more also. So I add both negative and positive. So positive deviation are subtracted and negative deviation are added to left hand side to balance the equation. Got it? So our constraints and objective function, pardon, got it? Let me move forward so that you can get better idea, you can understand more. What we do in solving the goal programming problem, what we do is step by step, I will try to explain. First, we transform the objectives into goals. And I said, we associate some target with our objective function. So our objective function was here maximizing, sorry, pardon, sorry. I think slides visible?
Yes, sir. Perfectly
Okay.
visible.
Okay, my objective function was maximizing AR X. So I have to convert into a goal. That means my function should be more than equal to a certain level targeted PR. Okay. And for minimization objectives, we have to do the reverse. Okay. Then we convert these into goal into equations. So as I said, we add deviation variables to left hand side of the goal equations, goals, so that the equation is balanced. So what we do is we add the negative deviation and subtract the positive deviations to our goal function. And as you know, both are not possible, because either we can achieve over or we can achieve under, but we cannot, they both cannot happen. So the subjected to the constraint that di or d minus multiplied by d plus are equals to 0, means one of these will be 0, other will be non-negative plus value. Now means this will be more than 0. So as I this I have explained it. When our if we want to maximize it, we or our overachievement we subtract, and underachievement we deduct from the goal equation. Then third step is to minimize or to identify the undesirable deviations. We have converted into goal into an equation. Now we have to decide which one is undesirable. And for maximization goal, negative deviations are undesirable. Suppose I want to maximize net return, so I don't want less than my target. So my undesirable is negative deviation. For minimization goal, these positive deviations are undesirable. Suppose I want to minimize water, so I want to minimize that it should not go access. Access I want to minimize. Or for exact goal, I want both positive and negative deviations are undesirable. Neither I want positive nor I want negative. Third is we rank or weight our goals based on the importance. Suppose my top priority is to earn the profit, and then my second priority is to reduce the water, and then my third priority is to fulfill my family obligations, means minimum quantity of food grains. Then like that, we either we weight or we rank it. Rank it in ranking. What we do is we achieve first we achieve first goal and then move to second, and in weighted we assign some weight and solve the problem at a time. Sorry, this step 3 and step 3 it has repeated, and for fifth step is compute pardon.
So some crosstalk.
Oh, then last step is we have to compute the undesirable deviations from aspirations and sum them up, so that and this becomes our objective function. This becomes our objective function. So now our objective function is different. I want to minimize the deviations. So my all goals or and all objectives has been covered, but I want that whatever my goals means the deviations from these goals should be minimum. So what I have done is I have formulated converted the LP problem, GP problem into a simple LP problem. So my objective here is minimization of sum of deviations from the goals subjected to the constraint that sum of this is this one positive and negative deviations. This is actual value plus negative deviations minus positive deviations equals to our targets, and only one of these will be at least one of these will be zero, and di's d plus and d minus are non-negative, and of course non-negativity of the decision variables. We cannot accept negative allocation. So I will request you to take the screenshot of it, and if you can take printout of it, it will be better. We will formulate a problem. Hello? Are you listening? Are you active?
Yes, sir. Yes, sir. We are with you.
So you do one thing, you take a screenshot of this problem and take a printout if possible, otherwise you take a screenshot of it. We are going to solve it. I am reading it. A farmer from a district of central India has 20 hectares of cultivable land suitable to grow paddy, and the yield of paddy is 25 quintal per hectare. Sorghum with yield of 8.4 quintal per hectare, pigeon pea 9.8 quintal per hectare. In Kharif, he can grow 3 crops. First is paddy, sorghum, and pigeon pea. And in Rabi, he can grow chickpea with yield 8 quintal, mustard with yield 6.9 quintal, and wheat with yield of 24.2 quintal. So he has 6 crop to grow. He can grow 6 crop, and in Kharif he can grow 3 crops, and Rabi he can grow 3 crops. The per hectare net economic margin from paddy, sorghum, pigeon pea, chickpea, mustard, and wheat are given here. Okay.
Okay, sir.
And crop wise unit requirement of labor and working capital are given below in this table. Understood? He has 7 permanent labor and allow them to 1 off days a week. They can go only for 1 day in a week. Being agricultural economics suggests to farmers how much area to allocate under different crops if he has sufficient water availability from canal and want to maximize net return. Further, he has to produce 10 tons of pulses, 1 ton of oilseeds, and 20 tons of cereals to meet his obligations, because he has to give to his laborers this much quantity of cereals, pulses, and oilseeds. Not that he has 4 lakhs rupees 4 lakhs in his hand to meet operational expenses. Can you formulate this problem? Because I'm asking, because you had the previous lecture of Dr. Kingsley. Can you formulate it? How many of you can formulate it? Can you formulate it? Will you try it? Or I should go directly to formulate the problem. I should once formulate and then ask you to formulate another one. No, you are not interacting. No, actually, the class is not enjoyable if you are not interacting. No, please. I should go to I should demonstrate first, and then we'll ask you to solve the problem, means to formulate another problem. Shall I do this?
Yes, sir. That will be better.
Okay. So I will open Excel file. I am unsharing this. Are you getting my present? Sorry. Okay. My Excel sheet opening. Can you see my Excel sheet?
No, sir, it's still opening, I think. It's still not open. It's still not open.
Oh,
It's taking time.
I'm stopping it
Yes, sir.
and again sharing it.
Yes, sir.
Okay, let me open it first and then reshare it. Now,
Now it's visible, sir.
okay. So you, as I requested, you kindly see to your screen, sir. Are you ready? What I said is he has 6 crops to grow, 3 in Rabi and 3 in Kharif. So I'm highlighting it. So this highlighted colors, no, actually I'm highlighting by yellow. He can grow 111 means I am saying that he can grow these crops in Kharif. Okay. One means if I'm saying that he can grow pigeon pea, paddy, and sorghum in Kharif, mustard, chickpea, and wheat in Rabi. Okay. These he can grow in Rabi. So my first statement is I have formulated in the form of LP. And then the yield are there. I think yield are there. You see this yield for, let me uncolor so that you can understand. Yield for Arhad is 9.8 quintal per. This highlighted, this one yellow highlighted, I'm highlighting this yellow one. These are, sorry, different color I will choose. These highlighted colors are the unit requirement or use coefficients. Okay. So 9.8 quintal is the yield of Arhar. It is giving pulses, so I have written against the pulses production law. Paddy cereal 25 quintal per hectare. Sorghum 8.4 cereal. Then mustard oil seed 6.9 quintal per hectare. 8 quintal per hectare, this one chickpea, and wheat 24.2 hectare. I have just put these in the form of coefficients. Okay. You can put in your Excel sheet. Simultaneously, you can put in your Excel sheets. Are you doing it?
Yes, sir.
You do it. You
Yes.
do it. Huh? If you require, I can share this means, but I don't have option to share it, how to share it. You can share means you can enter it, not big table. So you share it. Sorry, you enter it. My capital requirement here, another was the capital requirement. It's given in my table, below table. The working capital requirement for RR is 6,780. For paddy, it is 16,181. For sorghum, it is 3,519. For mustard, it is 5,496. And then for chickpea, it is 10,000 something. And for wheat, it is around 15,000. Okay. I have entered capital. I have entered yield. I have entered mandate's human labor requirement 61. I have just brought it from my table. Isn't it? The only thing to understand here is this one season. Here also I didn't do anything. I just put 111 means this particular crop can be grown in this season. And in second, this is one row number 3, I have put net return per hectare. And second row is my decision variable or decision row. Okay, decision row means the area to be allocated under different crops. Now my constraints are there. So what I have done, I have multiplied the net return with decision variable. That means area to be allocated under each crop, so that I can get the sum of net return from all the crops. Okay. Okay. I have done it. So I have done some product of decision variables and then net return. So I got the sum of net return from all crops. So this is my objective function. Okay. I said that he has only 20 hectare of land. So he has 20 hectare of land. So here I have put 20 and 20. Of course, it will be available in both the seasons. And then I said that he has 7 permanent wet labor with 1 off days in a week. So what I have done, I have multiplied 7 with 365 minus 52 means one day in a week. So it has given me the working man days. I have converted into man days. Kindly remember that your left hand side and right hand side should have same unit of measurement. You won't be able to solve a problem if you have different units. So third, I said that the capital availability with farmer is 4 lakh rupees. Okay, I said that he has to produce 10 ton of pulses, 1 ton of oil seed, and 200 tons of 20 tons of cereals. You can see symbols here. My land should be less than 20 hectare or less than equal to 20 hectare. My human labor should be less than this one. Working capital should be less than this one. Pulses should be more than this one. Okay. So the total will come from here. I just simply summed the sum product, done the sum product of decision variable with the unit requirement. So this yellow one is my left hand side. And this one is, these are the signs, and this is right hand side. Means this should be equal to this one. Oh, sorry, as per this science, this should be as per the science. So I will solve it. What I will do it, I will go to data and then data and then solve it. As Dr. Kingsley said, my objective is to maximize net return. So I will select which row, which cell I will select. I will select J3 because my net return from all the crops is mentioned in J3 column, so cell. So I want to maximize it, not minimize. I want to maximize it. So what I have to control is area under different crops. So my decision variable will be B2 to G2. Okay. So I want to change this one because I cannot change the labor. I cannot change my lane. I cannot change my all obligations. I can only change the area allocations under different crop. Okay. So decision variable will come in this cell, actually this particular. Okay. And then constraint will come here. Here, what I have done is I have selected at a time, means my cell reference means H4 to H7. That means my left hand side sum of all crops, the resource used from sum of all crops should be less than my availability, and availability is there in right hand side. Okay, so J4 to J7. Okay, yeah, I can select it again. Yeah, should be less than, sorry, it has selected twice. Anyway, I will delete it. Okay, okay, and then second is means I have to have my production of oilseed, pulses and cereals more than this one, 10 ton, 1 ton and 20 ton. Okay, I have selected that one. Okay, just I will solve it. Solve using simplex LP. I have solved it. It has allocated area. You can see. You can see it has allocated area 16 hectare, because my objective here is to maximize the net return. So it won't allocate, obviously it won't allocate to sorghum, because my target is not to minimize the water. So it will allocate to more to arhar, and then to meet the obligations of cereal production, it will also allocate some area under paddy. Okay. Then in kharif also it is allocating area. We can see here that the model is suggesting that you utilize entire lane and utilizing entire labor, but you have something left with you as a working capital, and then pulses production you have overachieved, oilseed just achieved, and then cereal also you have achieved. Okay, this was the simple, but situations are not so simple. We have to minimize water also, and sometimes what happens, no, actually we have to sacrifice somewhere. We are not sacrificing here somewhere. No, actually we are not compromising, which I should say is compromising here. No, actually we are rigid. that our labor should be less than this one. But in real life, it doesn't happen. Actually, we can hire more labor if we can earn more. So what we have to do is we have to be somewhat soft, no, not too much strict, no, actually too much hard. No. So our hard constraint, that is inequality constraint, should be converted into equalities. We should allow some flexibilities, and that flexibility is allowed by goal programming, and we can accommodate more number of constraints and objectives also. Okay, I have to explain the steps, not but I'm explaining the steps, not in the practical. Okay, so this was my simple GP, sorry, LP. So next is how to convert the LP into GP. Now I will just will stop it here and we'll switch over to this one PPT. Okay, where is my PPT? PPT visible?
Still not, sir, visible.
It's still not. So let me first open and then. Okay. Now,
Visible, sir.
okay. So we were here. We were here. So let us make it more complex, as the real world situations are not too that so simple. So now what happened? Now water supply in the canal has been stopped due to some administrative reason. He cannot use the unlimited water. He can extract groundwater from his only tube wells with capacity of 25,000 cubic meter water per year. So he can extract only 25,000 cubic meter of water to irrigate his 20-hectare field. Now additional burden came to his, the government is planning to impose limit on GHG emissions to 4 tons per hectare per year, beyond which farmer has to bear a strong penalty. Either he can reduce the GHG emission or he has to pay the tax for that. Okay. In other words, you can say that he gets the incentive for saving the GHG emissions. So two more dimensions have come. Other things are remaining. Given the following additional information suggests him the most satisfactory cropping pattern if water saving for him is twice important than minimization of GHG emissions. Not that as much as possible he don't want to reduce his profit and obligations of minimum production. Don't you think the problem has become more complex? Don't you think problem has become more complex?
Sir, obviously.
Obviously. अच्छा हो गया, complex हो गया. So what are the given irrigation water requirement? Sorghum doesn't require water because it rain fed, and paddy requires highest water, that is 4,500 cubic meters per hectare. These are the water requirement or water use coefficients, and global warming potential in CO2 equivalents. These are the GHG emission or factors. So can you do it? Now, can you formulate LP? Well, given the additional information, you try it. You take a screenshot of this. Can you do it? Please try. Yeah, I will wait for 10-15 minutes. 10-15 minutes. Shall I wait for 10-15 minutes and then ask you what is the answer? How much is allocate to different crops? No? How much is should allocate to different crops? No? Can you solve it? No, if you have any problem, kindly let me know. Did you understand something? At least something. No response. Anyway, okay. Let me solve it. Let me add some more dimensions and convert into GP and solve it. And that's up. I have time, no?
Your time is there, sir. By up to the
Okay,
5:30.
okay, 5 up to 5. I have half an hour. Okay.
5:30.
So I will stop sharing. I have few slides on my results of a practical, a case study of Bundelkhand region, but I think my practical in action will be sufficient to demonstrate what I have covered so far. Okay, so I won't share slides again. Is it okay? Is it okay?
Your Bundelkhand slide is visible.
No, but I means I have covered the theoretical aspect. So I want to stop my slides here and I will only explain in action. Is it okay?
Yes, sir.
Okay, I want to show my results. No one is interested in seeing my result. No, it's okay. No, I'm not. You should see the practical aspect of it. So how to do it, that is important. So I'm again sharing Excel sheet. Okay. This was my problem, not actually first problem. Okay. So I have added 2 dimensions. Simple. Actually, I have formulated. No? I have added 2 dimensions. I said that paddy requires, here you see, my cursor is moving. Cursor is moving. Why I have done in you, I can demonstrate it here also, but I thought that the sheet will become too lengthy and you won't be able to see it. So what I did is I did these calculations below this LP so that you will if you try, you will understand. So water requirement for means I have just added these 2 dimensions to the formulations of LP problem. So the water requirement for paddy is 4,500 cubic meter per hectare. Sorghum doesn't require water. RR require this much of water, means 150 cubic meter. Chickpea required 1,000 cubic meter of water. Mustard required this much of water, and wheat required. I said that he can accept 25,000 cubic meter of water. So my binding is 25,000 cubic meter of water. You can do it. Really, LP and goal programming are very, very much important tools to simulate the policies. I will demonstrate one thing, how you can simulate the policies and you can convince some in policy makers that if you change this one, this will happen. Okay, and not only social scientists, biological scientists also can use it. Very powerful tool, very powerful tool, very convincing. Then I have added GHG emission, and I said that he can, means he has to limit his GHG production to 4 tons per hectare. That means 80 tons, it's 80 kgs. 80, this is 8 tons, no? 80 tons, sorry. 80 tons, total GHG emission should be 80 tons. I have converted into kgs, no? That's why I was different. So I will solve this problem. First by LP, using LP, and then using goal programming. So I'm solving it, and what I'm doing is I have to maximize returns by changing my decision variable are here, by changing these, subjected to the constraint that my water, then this one lane, and then working capital, and then I will also select this one should be less than equal to this row, comma, I think it will work. I have selected at the time. Okay, no, it won't. I have to take separately. Okay, I have added one constraint. Then we'll add this is minimum area or minimum production constraint, that is pulses, oilseed, and cereal production should be more than my desired targets, no, my limits. Okay. Then I'm adding GHG emission, that's 3. I'm adding GHG emission, means my GHG emission should be less than 80 tons. So we'll solve it. Okay, solve it. I want to maximize net return. No, I'm only doing for one objective, but my only one objective is I can achieve by this one. I will demonstrate how I can achieve all the goals simultaneously. So I'm solving. It is saying that it is not possible to do these things. Not possible that you can minimize your GHG emission. You can even reduce the water, and then it's not possible. Saying that it's not possible. So what I will do is I will convert it into a flexible one. So what I said that I will add one negative deviation, under deviations, and one over deviations, yeah, overachievement rows to each of my objective function and constraint. Note that in GP, all the objectives and constraints becomes the goals. Here our net returns, or our objective was to maximization of return. So it becomes goal. Also minimization of water, it becomes goal. So I have brought these things here. Target value or goal. Okay, these are my aspiration levels. Okay, my aspiration levels, and I said in previous LP, I got that I can achieve the net return of rupees 7.557 lakhs, total return of 7.57 lakh from my 20 hectare field. So I want that my return should not go beyond this, below this level. I don't have option to add lane, neither in Kharif nor in Rabi. Okay, I have the labor availability this much. I can go above, but want to be near this one. My water availability is this one, means I can borrow some water if I get return how much I have to water I have to borrow. Similarly, how much working capital, additional working capital I will be requiring, or I'll be saving something. Pulses production, whether I will be able to achieve it or not, my aspirations is this level. Only just I have converted into these goals now. Goals means what I said, that I will add negative under deviations and over deviations. I can accept under deviation or over deviation, or over deviations. So what I will do is my obtained value will be here. This is my decision variable. This is my decision variable, means cell number B16 to G16. These are my decision variable. And of course, these deviations variable will also become the decision variables, because these will vary. So what I have done is I have allowed the flexibility by adding what? Adding negative deviations and subtracting positive deviations. You see from this formula, can you see it, formula? Are you able to see formula?
Yes, it's visible.
Okay.
It's visible, sir.
So means I can accept area less than my targeted area, means I want to target that there should be balance between all the crops. This is my target. I want that this should achieve, but I can accept less than that also if it is, if all the my targets are achieved to some extent. So I have added this negative deviation and subtracted positive deviation. Likewise, in all the six crops, I have added this one, equated this one goal into a balance equation. This is my equation, means goal expressed into equation. Okay, goal are expressed into equations. Return, you see, I have brought return from here. I have brought return from here. That means my net return per hectare multiplied by area. So that will give me the return. So this will be fixed. This will be fixed. Similarly, labor. Similarly, lane. Similarly, this one, labor. Then water. Then working capital. It is multiplying, same means multiplying the decision row with the per hectare requirement. Okay, decision variables, decision row is multiplying with the per hectare requirement. So I'm getting the actual obtained value. This is the row of actual obtained value, and this is the row of underachievement. Means this much I can accept underachievement, or this much overachievement I can accept, but only one of this. Okay. Okay. So what I have done is, for each, wherever I want to keep my constraint hard, I will just add only one. Okay, in case of lane, since I cannot have additional lane, so I can accept only the negative deviations, means unused lane only. Okay, so I have not subtracted the over deviations, or I have not allowed the over deviation. Okay. Similarly, in Rabi also, what I have done is I have not allowed the over deviations. Okay. For labor, I am flexible. If some additional labor is required, I will do it. Okay. And for this one, labor and then water, I am saying that I can manage additional water from my neighbor. If I don't want to do it, and or if I don't have that option, then what I will do? I will delete this. I will delete this. Okay, if I have option. Okay, minus. I will delete, means subtract this overachievement. So I'm allowing the overachievement. Similarly, working capital, because I can borrow from the bank also. So what I have done is I have allowed both under and overachievement. Pulsage production, I can accept less. Okay. Serial production, I can accept less or more. I can accept less or more. So my goal I have expressed in the form of equation. Okay. So my left hand side now becomes this row. And right hand side becomes this target values. Okay. Now I want that my deviation should be minimum. And what are deviations? These row number 17 and 18 are deviations. So rather than computing absolute deviation, what I will do is I will compute the relative deviation, percent deviation. Okay. So I have divided B17 by B20, means how much it is deviating from my target, either under or over. Okay. Is it okay? So I have computed deviations for all the decision variables, all this one objective function, and all the constraints, because decision variables, constraints, and objective functions now have become goals. So all have become goals. So I have computed deviations. So my 3 steps are over. Sorry, 4 steps are over. My next step is ranking or weighting the goals. Okay, I have done this here. I said that water saving is twice important than other. I have given 2. I have assigned here twice important, means twice important than other goals. You will ask why you have mentioned 1 here, not here, not here, here somewhere 1, 1, 1. This is because that in case of paddy, okay, I want that my underachievements are minimized. That means I want my area under paddy should go higher. Even under sorghum should go high. Okay, I should cover maximum area under sorghum in each crop cycle. I can write a 0 also. I cannot, means I can assign 0 also. Okay, but in case of written under deviation, I have written 1 because my target is minimizing the under deviations. I don't want to accept, or I want to emphasize or I want to give more weightage to minimize my underachievement. In other words, I want to give more focus on overachievement. So what is there? 0 means if it goes deviate over, no problem. It won't come into function. Okay. In case of lane, I don't want overachievement because I don't have the lane, more lane. Okay. So for those variable or those objective which I want to maximize, what I will do? I will assign more weightage to underachievements deviations. Because my objective function will become minimization of deviations. Okay. So I have assigned weights to each of these goals. And finally, I have, sorry, this will come to this. So I have summed up the deviations. Okay. So my objective function now becomes this one. Minimization of deviations from the goal set. Okay. By changing this decision variable or and also by under and over deviations, I can change, I can accept because I have control over it. Okay. This one also have become my decision variable because I can accept some to some extent under and over achievement, but weightage I have given that I want to minimize these deviations, under deviations or over deviations. So I have formulated this goal LP into, or I have transformed LP into goal programming. Okay. Now I will solve it. Very simple. What I will do is, as we solve the LP, my goal is minimization of deviations from the goal. So this has become my objective function. I want to minimize it by changing what? By changing this one and also changing this one. And I will put comma and sorry, I can change this also and this also. So I want to change, or I can change this one. So my decision variable is this one. And now these will, I will delete, these I will delete, these I will delete. So my constraint is my this one, what? Right hand side, this one. Sorry, it has clicked here. And that means my real total should be equal to my targets. Okay. Solve it using syntax. It has solved. It has allocated 14 hectare to sorghum, 6 hectare to arhar. Okay. Earlier it was allocating more to arhar because our target, our goal has become, our goal also to reduce the water. So it will allocate more area to sorghum. And in Rabi also it has almost balanced. Rapeseed, mustard also, then wheat it is allocating less area because wheat relatively require more water than chickpea. Okay, it has taken care of water also, greenhouse gas emission. But you see, the net return achieved are only 3.91 lakh rupees. The farmer will sacrifice underachieve 3.66 lakh rupees. Okay, 3.66 lakh rupees. Entire amount, the 5 hectare of land in Rabi will be underutilized, unutilized because he don't have water. He has additional obligation of GHG, reducing GHG emission. Also, he has unused labor, irrigation water. He has to borrow some irrigation water, even though he has this much. He has compromised the return. He has to take additional water from his neighbor. Working capital, of course, less than pulses production. He cannot achieve this pulses production. Sorry, he can achieve. He is overachieving pulses oilseed, and the cereal production is just achieving. Emissions is reducing it to very low, 20,000. Okay, if I want to do sensitivity, means if I want to give more weightage to what? To returns. So my under returns should not be less. I won't accept. I will prefer I will give more weightage to return. Then I have given weightage to return. We'll solve it again. Simple. Okay. You see, return has been increased. Okay, returns have been increased. But what is required? He will require more water. He has to arrange more water. Okay. If I give more weightage to, suppose I am not giving weightage to this one, rather I am giving weightage to water more, I can do it. So, okay, yeah, it has given more priority to water. You see, water remain within the limit. Okay. Any? Did you get something? I will share these slides and this Excel sheet also. But only if you will respond whether you get something or not. If you won't respond, I won't share this Excel sheet. Only PPT. Okay. How many of you understand something? Was it a bit clear? No? Okay. I will provide these slides and Excel sheets to Dr. Vikas and Dr. Rajni Jain. She will share with you. Okay. Any feedback?
Any queries there from the side of participant? Any issue regarding this? Sir has explained very nicely through Excel how to solve the issue. Please inform through chat box also. I think
No,
you have understood.
had very heavy lunch, so all are sleeping.
So participants have written. It's a nicely explained with good examples.
Okay, thank you, Dr. Saab, for giving me this
So,
opportunity.
Thanks,
I will
thanks
see.
Akshay, for your good lecture and nicely explanation to our participants. And any other query is not there, I am supposing.
You can write me on through email also. You can contact me through email also. I can help you if you are interested. My email is there on our website. You can
You can interact with sir through website. All details are available on your website.
Yes, sir. Even if you call me over phone, I won't mind.
So I'm thanking Dr. Saab for a wonderful lecture. And any other issue is not there. Thank you, sir, for nice explanation to our participants.
Thank you, Dr. Saab.
Thank you, sir. So this is for today. And tomorrow classes will be starting at 11:30. So we are ending the day for today. Thank you all. If any issue is there from the organizer side, please inform us. Now the session is closed for today now. Thank you all participants. Thank you. Yes, sir. Please speak.
सर जो ग्रुप बनाया है उस ग्रुप के अंदर जो लीडर्स हैं ग्रुप लीडर्स दोनों ही कनेक्ट नहीं हुए सर
सर कैसा इशू मैं समझ नहीं पाया.
ग्रुप फर्स्ट में ग्रुप लीडर है डॉक्टर अपर्णा एंड डॉक्टर प्रवीण बोथ वर एब्सेंट टुडे.
अच्छा ठीक है सर, इसको देखेंगे